Hello, Cap&GOWN scholars. You are back with Mr. Bradford for today's ACT topic, ratios and proportions. All right, let me just say that many of the ratio and proportion questions on the ACT are of the pre-algebra level, but they put them in word problems just to up the rigor, up the difficulty. But they're usually found in the beginning of the ACT, one of the first 20 to 30 questions. All right, quick review on ratios and proportions. All right, here's a simple ratio. This little chart just means, hey, for every 1 minute, you travel 1 mile. Okay, if I write that as a ratio, 1 minute, I travel a quarter miles. All right, but then comes a question. Well, how many minutes will it take me to travel 1 mile? Well, how many minutes? That's what I don't know. Will it take me to travel 1 mile? All right, well, I can write this as a proportion. A proportion and ratio are the same thing, they're just written differently. This one, a proportion is written with an equal sign. So it's like an equation. So if I wanted to set this up, I would say in 1 minute, I travel a quarter mile or 0.25 miles. And well, I don't know how many minutes it's going to take me. I'm going to call it X to travel 1 mile. Well, I can do the same thing in both of these to solve this. All right. I can say, well, it takes me a quarter to make 1 mile, or 1 minute to a quarter mile. So if I multiply this by 4, that's how I get this quarter to equal 1. So I will do the same thing to the top and bottom. And this must be 4 minutes. And if I look at my chart here, if it takes me 1 minute here, and this is 2 minutes, and that's 3 minutes, well, this must be 4 minutes to equal the 1 mile. All right. I can do the same thing here. A quarter mile to get to 1 mile. I just multiply this by 4 and do the same thing here. That gives me 4 miles. Okay. I have another ratio. 1 soda cost me, I don't know how much, but I know that 5 sodas cost me $3.25. All right, so how can I rewrite this? 1 soda equals, or the ratio of, I don't know how many dollars. Let's write it as a proportion to help us solve it. 1 soda costs an unknown amount of dollars, but 5 sodas costs $3.25. All right, we can usually solve a proportion pretty easily by cross multiplying. So we'll say 5x. 5 times x is 5x. And $3.25 times 1 is still $3.25. Divide both sides by 5, and we end up with 65 cents. Okay? So if I add a 65 cents to every can of soda, I'll end up with $3.25. Okay? Let's take a look at an ACT problem using ratios and proportions. All right, here's one of the more basic ones to start off with. If Earl can type 80 words in 3 minutes, how long will it take him to type 400 words working at the same rate? All right, so let's set up a proportion. All right, type 80 words. So let's put our words here. And then our minutes down here. Earl can type 80 words in 3 minutes. All right. So how long will it take him to type 400 words? Let's keep our words all on the same line at the same rate. So how many minutes will it take him? That's what I don't know. Well, the good thing about this is I know that 8 will go into 40 5 times. So this is just this multiplied by 5. 80 times 5 equals 400. Well, if I multiply that to the bottom also, I keep my ratio, and that gives me 15. So X should be 15 minutes. That should be an answer of A. So these can be pretty quick and easy if you know how to set up your proportions or ratios. All right, let's take a look at another. This one's also not too bad. On a map, 6 inches represents 240 miles. How many miles would 9 inches represent? All right, so let's put my inches here and my miles here. So my inches, I have 6 inches, which represents 240 miles. Then I have how many miles would 9 inches represent? That's what I don't know. All right, I don't have anything that I can easily use a common multiple or a common factor. So I'm going to cross multiply. Cross multiply these guys, and I get 6x equals 9 times 240. And I'm going to divide both sides by 6. And when I do that, I should get 360. Just checking my calculator. They get 360 miles. Again, they can be pretty quick. You can probably do them in a minute or less if you set up your proportion correctly. All right. Take a look at a little bit harder one. All right, on level ground, a vertical rod 12 feet tall casts a shadow 4 feet long. So let's draw that. I got a vertical rod, cast a shadow that's 4 feet long. So I'm just gonna make a little sun here. That's my shadow, and it is 4 feet long. And it's 12 feet tall. Okay. At the same time, a nearby vertical flagpole casts a shadow 12 feet long. How many feet tall is the flagpole? Well, let's draw a flagpole here. It's a little bit bigger. Okay. And it's casting a shadow also. Okay. And it tells me that its shadow is 12 feet long. And I want to know, how tall is this flagpole? Well, let's set up a proportion. Okay. So we'll say how tall they are here, and the shadow, how long the shadow is. Okay, so I have 12 feet to how tall this flagpole is. Then I have 4 feet long to how long this shadow is. This one works out pretty easily because 4, I can multiply by 3 to get to 12. And let's do the same thing to the top. multiplied by 3. That means that this should be, x is going to equal 12 times 3, which is 36 feet tall. And we can see our answer is E here. Again, if you can set it up properly, you shouldn't have too much difficulty with these problems. Okay, here is a proportion question with some geometry involved. All right. And the key to this problem, I'll tell you in just a second, is the word similar. So it says in the figure below, triangle ABC and triangle DEF are similar triangles with the given side lengths in meters. What is the perimeter, need that, in meters of triangle DEF? Well, what it means for these triangles to be similar is that they are proportional to each other. All right. One side is proportional to another side. So we have to pay attention to the letters here and how they're arranged because they have to go in order. So if I have AB is going to be proportional to DE. So if I look at AB, here's AB, which is 6, it's going to be proportional to DE, which I don't know yet. So let's set up a proportion. Say AB is going to equal, or it's going to be proportional to DE. And let's pick another side. Let's say AC. AC. Here's where A and C are. So I need to stay in the same order. That means I'm going to look at DF. So AC is 10. DF is 5. I'm going to say AC to DF. All right. So now I'm going to put in some values for these. AB was 6. AC is 10. DE is what we don't know. I'm going to call that DE. And DF is 5. We can kind of easily see here that to get from 10 to 5, you can divide by 2. All right, so we'll do the same thing for DE, which means DE is equal, 6 divided by 2 is 3. All right, so we can go over here and look at A. A is 3, but if you thought that was your answer, you moved too quickly. All right, 3 is a distractor. You need the perimeter. You need the perimeter. All right, so we know that this is 3 now. Okay. And if we had looked at it closely, we would have seen this is 6, this is 6, and that's 10. We would have seen that, hey, if this is 3, this has to be 3. Also, if everything is proportional. Okay, so we could have saved some time, not even having to do this if we had seen that these are going to be equal to each other. All right, but I wanted to show you how the proportion was set up. All right, so let's do our find our perimeter. Okay, that's 3 plus 3 plus 5. That gives me 6 and 5 is 11. All right, so our answer in this case is C. All right, let's take a look at a few more. They get harder. They get a little bit harder. All right, in this case, we have two similar triangles. There's that similar triangle again. And they have perimeters in the ratio of 3 to 5. The sides of the smaller triangle measure 3, 5, and 7 centimeters respectively. What is the perimeter in centimeters of the larger triangle? All right, so this must be the smaller triangle. So let's find the perimeter of the smaller triangle. And we can do that just by adding them up. 3 plus 5 plus 7 gives you, that's 8 and 7, which is 15. Well, the ratio is 3 to 5. This has to be the smaller because 3 is smaller than 5. This is the larger. Okay, so if this is my perimeter of the smaller, how can we determine the perimeter of the larger? Well, I can get from 3 to 15 just by multiplying 5 by 5. 3 times 5 is 15. Let's do the same thing here. And 5 times 5 is 25. So the perimeter of the larger triangle is 25. And that would be J. All right, hopefully everybody saw that. Now let's take a look at one more. This one's a little bit different, and I'm going to take a little bit different approach. All right, in a certain rectangle, the ratio of the lengths of two adjacent sides is 5 to 2. All right, so I'm going to draw that. I have a triangle. My longer side is 5, and this side is 2. And if the area of the rectangle is 90 square inches, so this area has to be 90 square inches, what is the length in inches of the longer side? So I need this side. I need to know what this is. I don't know what that is. Okay. I'm going to set up a little bit different proportion. All right. Now, just so you know, we can use answer choices to help us, but I'm going to kind of do it the long route just to show you the proportions or the ratios. So my ratios are 2 to 5. And when I multiply these together, when I try to find the area, I have to multiply those two things. So, or my base times my height. In this case, I get 10. All right. So that cannot be the length and my width. But let's use some ratios that might help us. So let's say I multiply both of these by 2. Okay. So that will give me, this has to be 4. And this has to be 10. Multiply both of them by 2. All right. 4 and 10. Well, it's 4 times 10. If I find my area, does that give me an area of 90? Nope. It gives me an area of 40. So that doesn't work. Let's try one more. Let's multiply both by 3. And so 2 times 3 is 6. And 5 times 3 is 15. If I multiply these two together, does my area equal 90? Yes, it does. So I can quickly see that my longer side is 15. 6 is the shorter side, 15 is the longer side. So my answer is C. Again, I could have used my answer choices to plug in and use that to find my answer. But again, I wanted to show how I'm using the proportions to kind of help me figure this out. Okay, that was probably the hardest of the problems, and we knocked it out. So That's it, everybody. Thank you for tuning in. We'll see you next time. Remember, where you going? College. All right.